Welcome back once more to Learning with Bunty Bhaiya on his makeshift whiteboard. Uh, I I don't know, dude. When I was writing this problem over here, I realized that I may have skipped a few steps, but it's fine. Now we are here. I promise that we'll be solving a problem without Excel, without any computer. So I've tried to keep it as simple as I could, and I have only introduced warehousing and sort of transportation in this as a constraint in this entire problem. Now the numbers might be huge, so we might not do like step by step calculation, but I hope this clarifies what I was trying to explain in my last video when I introduced the supply chain perspective in the later half. Now, just to give you a very quick introduction to the problem, I've tried to keep it as relatable uh, as I could, honestly. There's a company called Bunty Ice Cream, which has two distribution centers. One is in Ghaziabad, the another one is in Gurgaon. Both of them, the capacity here, if you see, it's 100,000. Both of them can hold 100,000 ice creams at once. Now the occasion is that Bunty Bhaiya party won, the MLA seat in UP Chowdhury, which is essentially Ghaziabad. Now what they're planning to send this huge consignment. So that's why like Bunty Bhaiya party has put in the order to Bunty Bhaiya ice cream, a huge order, right? Because the money should stay in the family. Now, what they want to do is there are four locations in Ghaziabad, namely Saibabad, Rajnagar, Indrapuram, and Vaishali, where they want to send these ice creams. Now, the demand is that they want to send 40,500 ice creams in Saibabad, 22,230 ice creams in Rajnagar, 85,200 ice creams in Indrapuram, and 47,500 ice creams in Vaishali. The numbers that you see over here is the cost per unit per kilometer over here that you see. So it's from Ghaziabad to Saibabad, it's 52 rupees. From Gurgaon to Saibabad, it's 45 rupees, and so on. Now, the question that we are trying to solve, the very basic question, we start with the very basic one, which essentially is at a minimum cost, how many units? Basically, what we are trying to figure out is if we have to keep the cost at minimal, what is the highest number of ice creams that can be shipped from the Ghaziabad warehouse to fulfill the demand? So, the entire demand, if I have to total it right here, okay, this is not working, let me change it. Yeah, so I'm back again with the blue pen. So if I were to just sort of very quickly sum this up, it's nearly, I think, 40, 50, 60, 80, 140, 180. So it's 180 plus 5, 6, 7, 7, 7, 14, 14,000, and then you have 5, 6, 7, 8, 9, 14, 30. You have 14, 30, so total 3, 4, 5, 9, 1, 195,430. This is the total demand. Could be a little here and there, but this is where we are in terms of concept. Now, out of this, we are trying to figure out what is the maximum number that I can send out from Ghaziabad, right? Now, we know the capacity of Ghaziabad is 100,000, but is sending, 100,000 is logical from, if we want to, it seems like it, but let's not look at the numbers because numbers are pretty clear over here. But let's say there's a case where this number is not so evident, that there's 100,000 that it holds at one point, but can you send everything? Because like right now, if I compare visual, I don't need laptop or anything for this. For example, 69 is smaller than 76, so this is cheaper. 11 is smaller than 15, this case is also cheaper. Then you have 32, again cheaper than this, or I don't know, cheaper than this, then cheaper this one's slightly more expensive, and that's why I compared here, this and this. So basically in all cases, Ghaziabad sending materials eventually will lead to a lower cost. So in this case, I can send all 100,000, which is the total capacity, from Ghaziabad itself, and rest 95,400 I can send it from the Gurgaon warehousing. But let's say, what was the case if there were some cases where, let's say, instead of this 32 it would have been 85, which means this was higher. Let's say this would be another thing where, let's say, instead of I don't know, let's say instead of this being 7, this being 100, this would have been 110. And just imagine after that, the 69, this is the only, sorry, we'll keep 69 here, but this is the only number that eventually was smaller. Let's say this was 14. Now you need to figure out that how much, so this is the only number that's the smallest across all of this, right? So we need to figure out how many can we send from Ghaziabad to Vaishali, because this is the lowest loop. Between these two, this is the logical thing to select, right? So you would, instead of the 100,000 that you're sending right now, you would only send 47,500, and rest you will send from here. So this is the kind of problem. This is what I mean when you keep introducing constraint, you change values. In this case, we were lucky that okay, most of it was smaller than the other part, so we could just send 100,000. But you understand what I'm trying to get at. So sorry. So this, to answer this one, it's 100,000 for this. Now what I want you to, like, of course you're not going to reach to a number you can solve and give me the answer later on, but now here what you're trying to see is what is the minimum cost to deliver. Here we were looking at the unit, so it was pretty evident here what is the minimum cost to deliver. Now again, I'm not going to solve the problem here right now, but the, if I look at the original numbers, which is this right here, this is the demand. We cannot exceed our, we cannot send more than the demand to each places. So let's see, look, there's a reason I chose this, because it's visually you can solve it. So when I have to send it to Ghaziabad, which is the number that, from where should I send it to, it's logical that I do it from Gurgaon. Here you go, right? If I were to do it individually, again, listen to me, okay? I'm not saying this is the correct answer, I'm just letting you know. Now, if you were to send it to Rajnagar, you would send it from Ghaziabad here. Now, if you were to send it from, if you were to send it to Indrapuram, which one do you select? Select this one here. And now, if you were to send it to Vaishali, which one would you select? Which one's here? So, but I don't know if you realize there's one key thing that we are missing. Maybe that it has already solved the problem here, but the key thing that we missed in this is we're saying that we used 40,000 units from Gurgaon here. Now we only have 59,500 left, right? Now, before, okay, in this example it's working, but let's say that the demand over here was greater than 59,500 when we selected it for 50, right? Then what would have happened is, let's say this demand, instead of 47,500, it would have been only, let's say, 60,000. Then how do you end up solving this problem is, you will send 59,500 by this, and then the rest 500 that you have, you send it to at the cost of 69. That's more or less how you can solve it. So this is what I was trying to explain in the systems perspective, that there are different constraints that keep changing your entire supply chain design at some point, or with time there are things that keep changing geopolitically, externally, internally. So these are the kind of things that you have to always sort of factor in when you are working with the supply chain. Now I do realize while solving this problem is that yes, this is a little too advanced for what all we have covered, but this was just to more or less introduce you to the topics, when how do we solve a problem when it comes to supply chain, when it comes to sort of designing a logical solution to any supply chain problem. Again, all of it what I said was just to give an example. It was not something that I was trying to solve 100%. It was just to give you an example, or rather flavor of how do you solve, what are the things that you can, what eventually you can do in a supply chain problem. Right now we only introduced warehousing and also transportation constraints, but there are a lot of other things that you can add here. So in the next video, let me sort of figure out that we take a step back from this one, we go back to the supply chain perspective, and we take the next step from there. तब तक के लिए stay happy, stay healthy.